To finish this chapter, we will look at an application of derivatives. And we will look in particular at the velocity and the acceleration. For this application, suppose that we have an object which moves along a straight line, and we will call this straight line, we will set it equal to the x-axis. In this case, the position of this object will be a function of the time t. So x is actually x of t, a function of the time. And then further, suppose that we measure x in meters and t, the time, in seconds. If we then illustrate this, we see that we have the line, the x-axis. On that line we have a certain object, and it can move only on the line to the left or to the right. Suppose that the object is moving along this line during a certain time interval, then we can define the average velocity of the object. So the average velocity over a time interval t up to t plus h, so the length of the interval is h, is basically how much it has changed, so the change in its position, divided by the change in time, so divided by the length of the interval. If we then want to write this down as a formula, we obtain that the average velocity, so v average, v for velocity similar as in physics, is the change in position, so delta x, divided by the change in time, delta t. So this is x at the moment t plus h minus x at the moment t. So the change in position is the end position minus the begin position of the object, divided by the change in time, which is h, and then expressed in meters per second. But usually we are not interested in an average velocity, but in a velocity at a certain time point. So the velocity vt of the object at a fixed time t, this is basically the limit of the average velocity if my h goes to 0. So if my interval becomes just a single point. So the velocity v of t at time t is the limit of the average velocity for h going to 0. So it is the rate of change or the derivative with respect to the time. So v of t is dx dt, so the derivative to t, or it is x prime evaluated at the moment t. As such, the velocity will not only tell us how fast the object is moving, but also in which direction. If vt is positive, so vt positive, this means that x is increasing, and so it moves to the right, the object moves to the right. If you have the inverse, so vt is smaller than 0, this means that x is decreasing, so x becomes smaller after the movement. So my object has moved to the left. The critical point of x is the time point t, so it is the time t where my derivative vt becomes 0, so x prime of t is 0. At this point we say that the object is instantaneously at rest. So at that point t, the object is not moving. How are speed and velocity then related? So speed versus velocity. Basically, the speed only involves the rate of change, but not the direction. So speed, what's important there is the rate of change, not the direction in which it moves. So the speed will tell you how fast the object is moving, but not where it goes to. So basically what you have, your speed s of t, is just the absolute value of your velocity v of t. But not only the velocity is important, also the derivative of the velocity has a useful interpretation. The rate of change of the velocity, so the derivative of the velocity with respect to the time, is called the acceleration of the moving object. So at time t, the acceleration a of t is the derivative of the velocity, so it's v prime of t, also written as dv dt, or it is the second derivative of x, so d squared of x dt squared. And then the acceleration is measured in meter per second squared. So it is the second derivative of the position x, and also here we can look at the sign. If the acceleration at is larger than 0, then at that time the velocity is increasing. If a of t is smaller than 0, then at that time point t, the velocity is decreasing. One remark to acceleration. So a positive acceleration does not mean that the object is speeding up. So at positive does not necessarily mean that the object speeds up or goes faster. Why not? If, for example, my object moves to the left, and my acceleration is positive, then basically what it does, it is slowing down. It's slowing down. Why? Because it is moving towards the left. It's moving to a smaller value, but the acceleration is to the right. So basically it is halting, it is slowing down the object when it is like this. So in the same sense, if my object moves to the left and a is negative, then it will be speeding up. If it is moving to the right and a is positive, then it will be speeding up. But if the direction and the acceleration have a different sign, then it slows down. Let's now apply this to the following example. So we have a point P moving along the x-axis, and it moves in such a way that the position is given by the function 2 times t to the power 3 minus 15t squared plus 24t meters. For this point, find the velocity and the acceleration of P at a time t. In which direction and how fast is the point moving at the time point 2 seconds? Is it speeding up or slowing down at the time? When is P instantaneously at rest? When is its speed instantaneously not changing? When is the point moving to the left? When is it moving to the right? And determine also when is it speeding up or when is it slowing down. So recall the equation. X of t was 2 times t to the power 3 minus 15t squared plus 24t meters. To find the velocity, we just have to derive this expression. So v of t is x prime of t, which is then 6 times t squared minus 30t plus 24 meters per second. The acceleration we derive again, so this is v prime of t. This is 12t minus 30 meter per second squared. We can simplify these expressions a little bit. So the first one is 6 times t minus 1 times t minus 4 meter per second. The second one is 6 times 2t minus 5 meter per second squared. For b, we have to see what happens at the moment t equal to 2 seconds. So we just plug it in. We get that the velocity in the point 2 is equal to minus 12 meters per second. And the acceleration at the point 2, this one, is equal to minus 6 meters per second squared. So we can say that the point P is moving to the left. Why to the left? Because my velocity is negative and it moves to the left at a speed equal to 12 meters per second. Furthermore, we see that both the velocity and the acceleration are negative. So they are reinforcing each other, they are pointing in the same direction, so the point is also speeding up at this moment. For c, we have to see when is the point at rest. The point is at rest if v of t is equal to 0. V of t was equal to 6 times t minus 1 times t minus 4 meter per second. So this is 0 at the point t is 1 second or t is 4 seconds. In the same way, we can see when the speed is not changing. So the speed is not changing if the acceleration is 0. The acceleration, we look again at the expression. This was 6 times 2t minus 5 meters per second squared. This one is 0 if 2t minus 5 is 0 or t is 5 over 2 seconds. To see when the point is moving to the left or to the right, we basically have to look at the velocity over all different time points, so we make a sign chart for the velocity. For the velocity, we had two critical points, so 2 points where we had a velocity of 0. This was 1 second and 4 seconds. So here the velocity is 0, and it means that at these points the velocity can change of sign, not necessarily, but it can change. So we have to look at what happens to the left of 1. To do so, we just take a value of t which is smaller than 1 and we plug it into the equation of the velocity. If we do so, for example, take t equal to 0, plug it into the equation of the velocity, then you find 24, and so here the velocity is positive. For the points between 1 and 4, you do the same thing. You plug in a value. You will see that here the velocity is always negative, and for the last one it is again positive. So this means that the point is moving to the left between 1 and 4, so on the open interval 1 to 4, and it is moving to the right on all the other points except 1 and 4. So to the right is from minus infinity up to 1 and from 4 to plus infinity. To see when the point is speeding up or slowing down, we have to look at the acceleration, and we have to combine the information of the acceleration with the information of the velocity. So what we do is we make a sign chart for the acceleration. For the acceleration we had one critical point, so 5 over 2 seconds, and we do the same. What happens to the left of 5 over 2? What happens to the right? To the left we have negative values, to the right we have positive values. And then you have to combine this with what we found in D, so with what we saw in the velocity. If we then have that the point moves to the left, plus my a of t is negative, then it will be speeding up. Same thing moving to the right, plus a of t positive is also speeding up, and everything else is slowing down. So we combine now both of the sign charts. We have three important points, so the point 1, point 5 over 2, and the point 4. We know that v of t is 0 in 1 and 4. We know that a of t is 0 in 5 over 2. We plug in the values, so here this was positive, negative, negative, and positive. And for a of t we had negative and positive on the right side. We then said before that if they have the same sign, so if they are reinforcing each other, then we have speeding up, else we have slowing down. So in this case, here between 1 and 5 over 2, the object speeds up, and the same if the time is larger than 4. Because the sign is the same thing. If it is smaller than 1, my vt is positive, my a of t is negative, so here it slows down. The two, so the acceleration and the velocity are not reinforcing each other, but they are hindering each other. Same thing between 5 over 2 and 4. Here also the object slows down.